So example 2, it wants us to find dy dx, and we have y equals an expression raised to the third power. So the outside function is what we're calling f. We're taking the derivative of something raised to the third power. Now we could take the time to write it down if we want to. F of x equals u cubed, but usually we won't. We'll just realize we're taking the derivative of the cubing function composed with 3x squared plus 4x plus 5. Since it's the first one of today, I feel like it would be good if I would be as deliberate with this as possible. So let me throw in the extra variable, and then again quickly without the extra variable. If we're going to throw in the u, what we would say is that u equals 3x squared plus 4x plus 5, the inside function. That's u. We did one similar to this last time. It might have been the same example, or one just different by a number or two. Very, very similar example. And also then y equals u cubed. But that's a good feeling in a math class when you're sitting there thinking, I've seen this somewhere before. Even if it was just the previous class period. That's a good feeling rather than, I've never seen anything like this before in my life. How am I going to do this? Du dx equals 6x plus 4. We take that derivative. And dy du equals 3u squared. We take that derivative. And then according to this up here, we multiply dy du by du dx. So dy dx equals dy du times du dx. That's going to be 3u squared times 6x plus 4. And then it has a u in it. We were expecting it to have a u in it. So we substitute 3x squared plus 4x plus 5 for that u. So this is 3 times 3x squared plus 4x plus 5, quantity squared, times 6x plus 4. Other than factoring a 2, maybe out of the 6x plus 4, that's the final answer. So in looking at this, what we observed last time, right at the end of class, was that if we wanted to take the derivative of 3x squared plus 4x plus 5, quantity to the third power, then you could think of it as using the power rule. It's kind of a generalized power rule, but you could think of it as using the power rule. You'd take the 3, bring it out in front, and there it is right there. You'd reduce the exponent by 1 from a 3 to a 2, and there it is right there. And so you would have 3 times whatever's inside the parentheses raised to the second power. Now the thing we have to keep in mind is, and I'm saying it for the second or third time now, I'm going to say it probably 20 or 30 times more, the chain rule says multiply by the derivative of what's inside the parentheses, the inside function. We have to multiply by the du dx. So we multiply by 6x plus 4, and that gives us the answer. Now, using the generalized derivative formula, when we look at this, here's the way we want to think of it. Y equals an expression raised to the third power. Well, the derivative of an expression raised to a third power is 3 times that expression raised to the second power times the derivative of that expression. That's the way we want to think of it when we're evaluating the chain rule. Just how do we take the derivative of something raised to the third power? Well, bring 3 out in front, reduce the exponent by 1, and then multiply by the derivative of that expression. Let's